good morning, good afternoon. I don't know at what time you're listening to this, Professor, but I will start by explaining why the y variable has to do with the x variable. So, in this side, the x variable are years, and the y variable is sales. So, each time the years are changing, the sales are increasing or decreasing. But in this point, they're increasing. And that's how they're related. So the first step was, well, as I said, I used a table and I graphed this. I also put a lineal line so you could see. And I also put my ideal line, the perfect line that I thought was the perfect one. And that was the first step, to find which one was the function that represented the best fit for the presented data. And I chose this because I think the polynomial function is the best one, because I was searching up ideas, and I searched on the internet, and I found that the perfect one is always going to be the one that's closest to R2 equals to 1. So I tried a lot of them, and this is what I did. Oh, I can't do it right now. Oh yeah, I can. Trend line, more options. I tried each one. I tried this one, and I also put the R2, but it was giving me a 0.98, so it wasn't the closest one. I also tried linear, and it wasn't close either. This one has nothing to do. The polynomial was the closest one. The power one gave me an R2 of, it's right here, 0.95, so that wasn't it either. So I just went for the best suited one, which was the polynomial, which was the closest one to what I'm saying. Let me just close this and I can continue explaining. For point number 2, I was supposed to say and specify my valid parameter in the case of regression, and my valid parameter was found in R2, which was 0.9941, and it belongs to the polynomial function. And it was the best fitted because it was the closest to 1, as I just said before. For point number 3, we're supposed to find statistical sales or revenue predictions for the years 1 through 10. And I represented this by graphing the original one, which was years in sales, and I also added another column, which is 0.3. And by this point, I substituted the formula that's up here. Give me a second. This formula right here, the y equals to 14.87 x squared minus 1101.3x plus 1346.2. And I did that for every single one, and x means years, so I just added the years, and this is what it looks like. So after that, we found that the orange points are the predictions, and the blue points are the actual sales. So it looks almost similar, almost ideal, but it's not, and this is because maybe there were more sales or less sales in the years as expected. And to explain the behavior, I'm going to start by saying that when substituting into the formula and graphing it, we can see that they're almost identical. Some are below the scatter plot because there were probably less sales in the company, as I just said, and there were some points that were above the scatter plot, which means that they were above what they were supposed to do, so they were gaining more money, as predictions were told. A better prediction could have been done by graphing a monthly sales of the company and also adding more years to see how the company is gaining or not gaining money from sales. So it would be better to add more information to these graphs, because it is good information, but it's only 10 points. We can't really see how the company's acting. We can see, but it would be better and more specified if we had more points into the graph. And that's it. That's my whole evidence. And if you have any questions, we can see them in the comments of the video or in my homework. Thank you.